Hi guys, in this video we are going to discuss about group 17 elements. I will be writing every important points in our syllabus. Please don't forget to take notes and please don't forget to revise. I hope you are ready. Let's hop into the video. What are group 17 elements? Group 17 elements are the elements with valence shell electron Ns2 and Np5. We call these elements as halogens. These are called as halogens. These elements are very reactive. Therefore, they are found as compounds in nature. Found as compounds in nature. They are found as compounds in nature. Now let's look at the elements of group 17. What are the elements of group 17? What is the first element? Let's look at the element fluorine, chlorine, bromine, iodine, and astatine. Astatine. In these elements, most electronegative element is fluorine. Most electronegative elements. Most electronegative element. Most electronegative element is fluorine. Then now let's look at the oxidation state. Fluorine forms oxidation state of oxidation state. Oxidation state. Chlorine form the oxidation state of 0 and -1. They form the oxidation state 0 and -1. Chlorine forms the oxidation state of 0 and -1. These elements, chlorine, bromine, iodine, and astatine, they form -1 to +7 oxidation state. Oxidation number. They form stable compounds, but they form stable compounds. In these oxidation state, these elements form stable compounds, but bromine 7 plus is unstable. Br 7 plus is unstable. Why fluorine has only one oxidation state? It is due to their small radius. They have smaller radius. Due to only one oxidation state, due to smaller radius. These group 17 elements form gases. Let's look at the color of these gases. Now let's look at F2, Cl2, Br2, I2 and At2. F2, Cl2, Br2, I2, At2. Let's look at the colors of these compounds. F2 is a pale yellow gas. F2 is a pale yellow gas. Cl2 is a pale green. Cl2 is a pale green. Pale green gas. Pale green gas. Br2 is a red brown fuming liquid. Red brown fuming liquid. Red brown fuming liquid. Okay. I2 is a violet black solid. Violet black solid. Violet black solid. I2 is a violet black solid. I hope you can see this. And this is a lustrous solid. It's also lustrous. In our syllabus, we don't have anything for 82. Also, fluorine can stabilize higher oxidation state of other elements. Can stabilize higher oxidation state of other elements. Let's write it down. Can stabilize higher oxidation states of other elements. Now let's look at the group trend. Let's look at the group trend. Group trends. Look at the radius. Okay. Radius down the group, it increases. Oxidizing ability. Oxidizing ability decreases down the group. Oxidizing ability decreases, this radius increases. Next, reactivity. Reactivity decreases down the group. It decreases. Reactivity decreases. And the bond energy decreases down the group. Next, we have acidic strength of hydrogen halide. Acidic strength of hydrogen halides. Acidic strength of hydrogen halides increases down the group. Hydrogen halides acidic strength increases. Next one is bond energy. Bond energy. Bond energy down the group, bond energy decreases. Bond energy decreases, but we have an exception here. We have an exception here. What is that? F2 has less bond energy than Cl2. F2 has less bond energy than Cl2. Br2, I2, AT2. This is the variations in bond energy. This F2 is exception. F2 exception. We can prove the reactivity decreases down the group using a displacement reaction. Let's look at the reaction. Okay, Cl2 in aqueous form plus Br minus ion to aqueous, they displace into 2Cl minus aqueous plus Br2 aqueous. This proves the reactivity. And now let's look at the reaction between Br2 aqueous plus 2I minus aqueous. In this displacement reaction, they form 2Br minus aqueous plus I2 aqueous. This proves the reactivity down the group decreases. reactivity down the group decreases. There are five trends in our syllabus down the group for group 17 elements. 1, 2, 3, 4 and 5. What is the reason for the bond energy decrease in bond energy for F2 than Cl2? What is the reason? Let's look at the reason. What is the reason? Due to the repulsion of non-bonded electron in F atoms. This is the reason for high reactivity of F2. High reactivity, therefore the bond energy decreases. Let's write the reason. Due to repulsion non-bonded electrons of F atoms. Therefore, reactivity increases and the bond energy of F2 decreases. This is the reason. Next, we will be discussing about hydrogen halides. HX. X means we resemble halogen. It can be any halogen, which is a group 17 elements. Hydrogen halides are acidic in water. Let's write on the point. Hydrogen halides are acidic in water. Let's write down the halides of group hydrogen halides of group 17. Okay. Now let's write the hydrogen halides. First HF, HCl, HBr and HI. The HF is a weak acid. HF is a weak acid and these are strong acids. Strong acids. HF is a weak acid and it has high bond energy. It forms a strong covalent bond. High bond energy. Reason for this? Due to strong covalent bond. High bond energy due to strong covalent bond. They form strong covalent bond. Therefore, it's hard to dissociate, difficult to dissociate. Therefore, difficult to dissociate. So it is a weak acid. HF has extensive hydrogen bonds. Extensive H bonds. They have the acidic strength increases down the group. Let's write the acidic strength. Acidic strength HCl is less than HBr and HBr is less than Hi. Our next subtopic is silver halide. Silver halides. Silver halides. Let's write down the silver halides. AgCl, AgBr, and Agi. Let's look at the color. AgCl is white color and AgBr is pale yellow. AgBr is pale yellow. Pale yellow. And AgI is yellow color. When going down the group, the color darkens. Solubility in ammonia. Now let's look at the solubility in ammonia. AgCl dissolve in diluted aqueous ammonia. Dissolves in diluted aqueous ammonia. And the AgBr, they dissolve in concentrated aqueous ammonia. Dissolve in aqueous ammonia. They dissolve in concentrated aqueous ammonia. And AgI is insoluble in both concentrated as well as diluted ammonia. Insoluble in con and diluted NH4 plus. Oxides and oxo acids of chlorine. Okay, let's draw a chart. Here we'll mark it as oxidation state, oxidation number, formula here. Let's write the formula. Let's write the formula of oxide. Formula of oxide. And here the formula of oxo anion. Here structure of oxo anion. Here structure of oxo acids. Structure of oxo acids. Let's look at these. First, we will be looking at +1 oxidation state. +1. Formula is Cl2O. The formula of oxo anion, ClO minus. Structure. Let's do the structure of oxo anion. O minus and a single Cl. This is the structure. Now let's draw the structure of oxo acids. Now let's look at the structures of oxo acids. Formula ClO. And let's draw the structure Cl and OH. This is the structure. Now let's look at the oxidation. Now let's look at the +3 oxidation state. The formula of oxo anion, ClO2 minus. Let's draw the structure ClO. This is the structure of oxo anion. Let's draw the structure of oxo acid. What is the formula of oxoacid? HClO2. HClO structure OClOH. Our next oxidation state is +5. +5. The oxyanions formula is ClO3 minus OCO. When we are drawing the oxo acids, we just add NH plus, where the minus present. H plus 2, the place where the minus present, minus charge of the oxo acids of +5 oxidation state, HClO3. The structure O double bond C O double bond OH. This is the structure of +5 oxidation state oxo acid. The next one is +6. Let's look at the +6 oxidation state. +6 oxidation state. We have two oxide, ClO3 and Cl2O6. The anion, we don't have any oxo anion. O oxo acid dash dash dash. +7 oxidation state, Cl2O7. The anion ClO4 minus. Let's draw the structure of oxo anion. OClO. This is double bond, double bond, double bond, double bond O, and a single bond O. Let's draw the. What is the oxo acid? ClO4. HClO4. The structure Cl double bond O, double bond O, double bond O, and the OH. This is the structure. Acidic strength increases with oxidation number. Increases with oxidation number. When the oxidation number increases, acidic strength increases. HClO acidic strength is less than ClO2. Acidic strength is less than HClO3. His acidic strength is less than HClO4. And the oxidizing power. Okay, oxidizing power of oxo acid. Oxidizing power of oxo acid decreases. HClO has greater oxidizing power than HClO2. HClO2 has greater oxidizing power than HClO3, and HClO3 has greater oxidizing power than HClO4. Now let's look at the halides. Halides of group 14 and group 15. Halides. Okay, the most covalent halides reacts vigorously with water, but carbon tetrachloride CCl4 does not hydrolyze. They do not react with water, but CCl4 does not hydrolyze. They do not react with water. Carbon tetrachloride does not react with water. Most of the fluorine halides are inert, and most fluorine halides are inert, and also some other halides are inert. Also some other halides are inert. So the most of the covalent halides reacts vigorously with water, but CCl4 does not react, and most of the fluorine halides and some other halides are inert. Now let's look at the chlorides of group 14 and group 15 reacting with less water. Okay. Chlorides of group 14 and group 15 reacts with less water. Around the two reaction, we have silicon and silicon chloride reaction and phosphorus chloride reaction. Okay. Silicon chloride CiCl4, which is a liquid, plus H2O liquid, they form SiO2 plus OHCl. This is aqueous and this is a solid. The next one, phosphorus chloride, PCl5. PCl5 is a liquid plus H2O liquid, they form POCl3 aqueous plus 2HCl aqueous. The next topic is chlorides of group 14 and 15 reacting with excess water. Chlorides of group 14 and group 15 reacting with excess water. We have 7 reactions. We have 7 reactions. Let's look at them one by one. The first reaction is silicon fluoride liquid plus 3H2O, here excess water. Excess water, here less water. They form H2SiO3 aqueous plus OHCl aqueous. Next one is NCl3, which is liquid, and it react with H2O. They form NH3 ammonium plus HOCl. Okay, let's look at the next reaction. They are with phosphorus. Phosphorus PCl3 liquid plus excess water. They form H3PO3 plus 3HCl. Okay. And the next one is PCl5, which is a liquid, plus 4H2O liquid. They form H3PO4. These are aqueous plus 5HCl aqueous. And we have other three reactions. Let's look at them one by one. These are a bit different reactions. I'll move this here. The second reaction is similar one. Okay, let's look at the next reaction. Arsenic, AsCl3, which is a solid, plus 3H2O liquid. It forms H3AsO3 aqueous plus 3HCl aqueous. 3HCl aqueous. These both are, the products are similar. Let's look at the next reaction. There are two reactions, antimony and bismuth. Let's look at those reactions. PCl3 aqueous plus H2O liquid. These are reversible reaction, and this is also reversible reaction. So to mention reversible reaction. Okay, BOCl. This is a solid plus 2HCl aqueous. Next one with bismuth chloride. Bismuth chloride plus H2O liquid. This is also a reversible reaction. They form BiOCl and 2HCl aqueous. Remember these both are similar ones. These both are similar reactions. This is also a special reaction with nitrogen. This one, they form hypochlorous acid. Here PCl3 produces H3PO3, PCl5 produces H3PO4. In every reaction, they produce HCl except this one, the nitrogen NCl3, except NCl3. Silicon and arsenic produces H2SiO3, H3AsO3. Antimony and bismuth produces SbOCl, BiOCl. The products look similar. This is the pattern, don't forget. Okay, the next heading is, next subtopic is reactions of chlorine. Reactions of chlorine. Reactions of chlorine. We know the chlorine is less reactive than fluorine. The reactivity decreases down the group. And but the chlorine gas, Cl2 gas, is a strong oxidizing agent. Cl2 gas is a strong oxidizing agent. Let's look at the reactions of Cl2 as strong oxidizing agent. Okay, the first reaction is with copper solid plus Cl2 gas. They form 2 copper CuCl, which is a solid, Let's balance this 2. And the next UCl reacts with chlorine gas and form 2CuCl2. The next reaction is with ferrum iron. Let's look at those reactions. Next reaction is with iron, ferrum, Fe solid plus Cl2 gas. It produces FeCl2 solid, similar to copper. And the FeCl solid plus Cl2 gas, they produce 2FeCl3 solid. Let's balance these two. Okay, we know need 2 here. Okay, our next reaction is with excess ammonia. We have learned this reaction in group 15. Let's look at it again. NH3 plus Cl2 gas. Here ammonia is excess ammonia. Excess ammonia, 8 gas. They form, what will they form? What are the products? They will form N2 gas plus 6HCl gas. And the next one is NH3 plus excess chlorine. Here they will react with excess chlorine. 3Cl2 gas, they form HCl gas plus NCl3 liquid. NCl3 liquid. NCl3 is a liquid. And here Cl is excess. Cl2 is excess. These are the reactions of Cl2 as strong oxidizing agent. As strong oxidizing agent. Our next subtopic is disproportionation reaction of chlorine. Let's look at those. Disproportionation reaction of chlorine. Disproportionation reaction of chlorine. When the chlorine is reacted with water and bases, they reduce as well as oxidize at same time simultaneously. Let's write it down. Chlorine is simultaneously reduced and oxidized when reacted with water and bases. Chlorine reaction with water, Cl2 gas, and they form hypochlorous acid plus HCl aqueous. Hypochlorous acid is a weak acid, we have learned this before, and HCl is a strong acid. Weak acid, strong acid. Here the oxidation state of Cl2 is 0. Oxidation state of HOCl is minus. Chlorine's oxidation state in hypochlorous acid is -1 and in HCl is +1. Here I'll mark it in purple color. Purple one, it is reduced, and the blue color one, it is oxidized. Okay, we learned about the reaction with water. Now we are going to look at the reactions with base. We'll look at the reaction with base. Reaction with base with cold diluted sodium hydroxide. Let's look at the reaction. Cl2 gas with cold diluted NOH, they form NaCl plus NaOCl plus H2O liquid, and these are aqueous. Let's balance this two. And now let's look at the reaction with hot diluted or concentrated sodium hydroxide. Let's look at this reaction. 3HCl gas plus concentrated or hot concentrated or hot diluted, hot concentrated or diluted NaOH, they form 5NaCl aqueous plus NaClO3 aqueous, NaClO3 aqueous plus 3H2O liquid. Here the difference is the numbers are different. Here 2, here we use 6, here we use 3, use 2 here, and the major difference is this one. Note it down, these are important. Next we have reactions of oxo anions. Reactions of oxo anions. Reactions of oxo anions. ClO minus, they are stable at low temperature. ClO minus is stable at low temperature, and they disproportionate into ClO3 minus and 2Cl minus and 2Cl minus. However, both BRO minus or IO minus, both BRO minus and IO minus, not stable at low temperature, and they do not undergo disproportionation reaction and undergo disproportionation disproportionation. And that is important point. HOCl is more stable than AClO minus. This is under acidic condition, and which makes the disproportionation predominance under basic condition. Under acidic condition, HOCl is more stable than ClO minus, which makes disproportionation reaction predominance under basic condition. And that's all for group 17 elements. I hope you understand. Meet you in the next video.